things unclear about, the whole idea of up, down, left, right.
Uh, Sometimes I normally get it confused and think the top number is the right and the bottom number is like up or down.
Okay. Yeah. And so this is like Matthew didn't make this up. This is just normal conventions. You have to somehow associate bottom with right and the top is up or down.
Right.
So that sign always goes with the top number. So occasionally you'll see something like this. You'll see a problem where it's let me not do that, where it's like y equals 1/2 like this with a negative out in front, x
Mhm.
minus 1. And you really want to, either you either do a rewrite or you mentally rewrite it and you say, okay, it's negative 1/2 x minus 1. That negative goes with the top number. So the
Right.
slope here is negative 1/2, but I want words. I want up, down, left, right. Can you tell me that for this slope?
Down one, right two.
Yes. It's okay to write this. Really isn't a big deal. They actually used to use in polar coordinates, use things like 4 right plus 2 up. They actually used to write coordinates like that were a little more clear. And in fact, if you're programming something, you might use something that's more meaningful to you.
Right.
So now the b value, what's the b value in this problem?
Negative one.
Negative what? Good. So when you go to graph this, do you start with the slope or the b value?
The B value.
Yep. And then you're going to go down 1, right 2, down 1, right 2. Okay, so now a question for you. I think you'll appreciate this. How many points are needed to draw a line?
Um, my teacher said two, but my middle school teacher said three.
So the answer is that you only need 2 points to draw a line, but the follow-up to that, you actually answered that is how many points does my teacher want?
Hmm.
And that could be different, but I think you just answered it. It's 2. So the point is that you can actually go and do this with 2 points. You might draw more to make it a better graph, especially if you're freehanding the line. I mean, you really should use a ruler, but 2 points are all that are needed. So don't get overwhelmed with basically the closer the points are together, the more you need
Okay.
to draw them. Something like this. Okay. Now, is it okay if I pull up some standardized test line graphing problems?
Yes.
Okay. All right, let me do that. So this is when it's in slope-intercept form. The next form that we usually talk about is point slope form, but it's kind of rare to get a graphing problem like this, but we'll talk about it. Let's say it's y minus 1 equals 2x plus 4. Okay. And again, let me draw the y minus y1 equals slope x minus x1. So can you extract the point and the slope from this?
Yeah, sorry. The point is negative 4, 1,
Good. What's the
and
slope?
the slope is 2 over 1.
Okay, so now give me the slope in words. Up, down, left, right. Tell me what's going on here.
Um, Up 2 to the right 1.
Okay. Up 2, right 1. Very good. All right. Now, in terms of how you graph these, it's actually really similar to the previous one. You first start at the point, though. So you go wherever that point is, minus 4, 1, you start there, and then you use the slope from that new point. So up to right 1, up to right 1, like that.
Mhm. Right.
Any questions on that?
Um, no.
Okay, so let me give you one to try. If you don't have graph paper, just try to make it reasonable. With your graph, give me reasonableness. But what I want you to do is to graph this function here. Okay, and when you're done, let me know. I'll graph it as well. We'll compare results here.
Yep. So um, so you say graph it? Okay.
Yeah, just a rough graph. Like I'm not looking for perfection. I want to see that your graph actually is just going in the right direction and through approximately the right points. But just make a as rough sketch as you want for me. This is one of the limitations of this format. I'll admit, I can't sit there and watch you graph it or, put a ruler in your hand, but just give me something.
Okay. So down to so. Oh wait, no. Down one. All right. Um, do you want me to turn on my camera and show you the
No.
graph?
No, I'm gonna graph it here. I just wanted you to, participate. Did you start your graph at -2, -1?
Yes.
Good. And then you're gonna go down 1, right 2. Does your graph look something like this?
Yes.
Okay, fantastic. All right, now we'll get into some more stuff with graphing, but we need to now do one in standard form.
Okay.
So I'm just curious, when you're doing any of your programming or thinking about with your robot, you've seen me do this a number of times where I sort of like branch, and that's what we've done here. It's like, is the problem in this form? Is the problem in this form, the point slope form, or now is it in the standard form? And you can see that there's like different ways to do it based on, where you're going.
Right.
And, simpler examples like, well, if I walk to school, it's this way. If I ride the bus, it's this way. If mom and dad give me a ride, it's this way. And that's kind of like that's how you program, by the way. I mean, that's you essentially look for these paths, these like cases, these things that differentiate one set of instructions from another.
Right.
Okay, so standard form, ax plus by equals c. Okay, so let me give you an example. Let's say we're supposed to graph 5x minus 4y equals 20. Okay, so there's
Yeah.
two options here. Option 1 is to solve for y.
And turn it into slope-intercept.
Yeah, and you do not want to do that unless like this approach does not work, which is using intercepts, which is what I want us to try here. This is the better way to do it. This will help you down the road. So
Okay.
here's the intercept approach. You say let x equal 0. Okay, so if you let x equal 0, and I'm gonna make a box here, you're now just looking at this part of it. Because 5 times 0 is 0, minus 4y equals 20. And then you're solving for y. So you divide both sides by -4. Y equals -5. Now, why am I doing that? Because we now have a point to graph.
Right.
That's one of the intercepts. Okay. So 0, -5, 1, 2, 3, 4, 5. That's down here. So this actually also works better in person, but we'll do the next one. Let y equal 0. If you can imagine, imagine your thumb covering up the -4y. What is left over? 5x equals 20.
Okay.
Okay.
Which would mean x equals 4,
Or
right?
so good to write the ordered pairs, especially if if you ever switch the variables, but x comes before y. There's the other point, and there's your line. Now, would you have gotten this doing slope-intercept form? Yes, but you don't want to do that unless you have to. I assume you've seen the intercept approach before, or is that not true?
Not really, no.
Not in a while. Let's do a few more of those, because it really is the better way. And you're a good enough math student, you should be willing to try this out. So let's do another one. Let's say it's -2x minus 3y equals -12. Okay, so I want you to set x equal to 0, then set y equal to 0, and I want you to give me the two intercepts, please.
Okay. If that's the case, then for y is when x is equal, right? Okay.
So you're literally putting 0 in for x. Now, what I didn't do here is I didn't show this to you because I really wanted you to just cover up the x variable, because it goes away.
Right.
-2 times 0 is 0. So essentially what you're left with is this part.
4.
-3, yeah, y equals +4. Good. And that's what I was trying to get you to like this works really well in person because I can cover up the -2x, and then I can cover up the -3y. Yeah, but anyway, keep going. Give me those.
If y equals 0, then x equals +6.
Yes. So this graph looks more like 4, 1, 2, 3, 4, 5, 6, something like that. Questions on that?
Nope.
Okay,
Thank
let me have you try. Now you should, okay, I'm really bad about labeling my graphs. Should label your graphs. But I did not. Okay, let's have you try one here. Let's say it's -4x plus 2y equals -8. So I want you to find the intercepts and give me a rough sketch of the graph, please.
Yes, sir. So the x-intercept would be y equals 0, so -2 for x. No,
If y,
+8.
yeah, be careful. It's so easy to be off by a sign, so just double check that.
And then y, for the y-intercept, x is 0. So that would mean it's -4. Yes, -4. And so the graph would be, wait, can you go back to the other graph again? Just one real quick.
Sure, yeah.
So your points are the x and y intercepts, those, right?
Yeah. So let me, I should have probably done one more with you. I like to go x equals 0, and then since this has gone away, it's 2y equals -8. I say, oh, it's y equals -4. And then I go y equals 0. because I really want them to be in this XY ordered pair. So y is 0, 2 times 0, 0. So it's just the minus 4x equals the minus 8. So x is 2. So those are your two ordered pairs, 0 comma minus 4, 2 comma 0.
Okay. Huh.
So this is down here, this is here, looks something like that.
Okay.
All right, let's have you try another one here. And I would recommend using this approach now that you've seen one is really it's x equals 0, then find y, then set y equal to 0 to find x. Let's try another one here. Let's go 3x minus 6y equals minus 18.
So the y-intercept would be 0, 3.
Okay, and then I like to come down here and put y equals 0 next.
And then the x-intercept would be -6, I believe. Yes.
Yep. Perfect. So then your graph here looks and then 0, 3 looks something like that.
Right.
Okay, do you want another example like this, or are you ready to kind of move on to some synthesis, which is really probably what you need anyway, is to look at different problems and know how to graph them.
Can we do a little bit different? Like instead of stuff like this, maybe more of inequality graphs as well.
Yes, so very different, but very good to do. So let me give you that's good. That's probably what we should do. Okay, let's say y is less than or equal to 3x plus 4. Okay, and you were asked to graph this. Okay.
Okay.
Here's what you do. You say, oh, I'm going to graph y equals 3x plus 4. So this is why we just did the first 24 minutes here. You need to be able to graph 3x plus 4 like this. So how do you do that? If you need a moment to look back in your notes, if you want me to scroll up, I can. Do you remember how to graph something like this?
We'd start at point 0, 4.
Start at the B.
And then we go up 3 to the right 1.
Good. 1, 2, 3, right 1. Like that. Okay. Now, when you're graphing, so normally you just graph a straight line, you call it a day. Okay. But with inequalities, you don't do that. Okay. You have to know a few things. This symbol and this symbol correspond to a solid line. This symbol, sorry, whoa, those are the same. Less than or equal to, greater than or equal to, or solid line. Less than or equal to, greater than or equal to, that's a dashed line. Which are we graphing here, a solid or a dashed line?
Solid.
Okay, so you have to make that decision. All right.
Mhm.
Now the next part is, do you shade above or do you shade below? Okay. And there's two ways to do it. The first way is based on the inequality. If it is solved for y, it has to be solved for y to do this. Is this solved for y?
Yes.
Yes. So what I'm about to say applies. Okay. If you have y less than or you have y less than or equal to, you shade below.
Okay.
Now, depending on the way the graph is, sometimes it's not clear what's below. I don't really have a great analogy, but like if I think of water coming down, I don't know if that's good enough. Like which side would I want to be on if this were my umbrella? I'd rather be on I want to be on this side. That's below.
Right.
in this one. Hopefully that's clear.
Yes.
And again, only if it's solved for, okay? You cannot use this justification because that's going to be your test question. If it's greater than or equal to, you shade above, okay? So there's added steps here when you're shading, when you're doing an inequality. You first graph the line, but then you got to decide if it's solid or dashed. Then you have to decide if you're shading above or below. Now I mentioned there was a second approach here. Okay, the second approach is to test a point. Have you heard of that?
Oh,
Have you heard of that in class?
yes. So you would put in like a random point for X and Y and see if it's in the shaded area, right?
Yeah, so it's kind of a logic thing though. Like we know, and this is not very good, but here's the thing: you typically want to test 0, 0. That's usually your best point. Okay, but keep in mind your point needs to be like away from the line. Like don't choose something that could be like really close to it. Don't choose like 1, 1 or negative 1, 1. That might be, if your graph is bad. You really need to pick something that's far enough away. Okay. Now, when you're testing the point, see, this has got its own complications. You're asking, is this true? Meaning like, is 0 less than or equal to 4?
Yes.
Yes. Now here's how the rule goes. You shade the true side. So since 0, 0 is true, that's the side you're going to shade.
Okay.
All right. So because I don't know if that was clear or not. We're gonna do related thing here about testing points. This comes from a standardized test question. One of these points works in both equations. Okay, and I'll just explain with coordinate A. All right, so we try A in both. Okay, is 2 greater than or equal to minus 2 times 1 plus 11? Is this true?
Wait.
So I'm trying A here.
Oh. Yeah. No. No.
No, so this is false. So that means A is out. Now, might as well try B. Don't have any reason. I don't know. But we'll just try here. And actually I did this completely wrong. I'm so sorry. Wow. I put the variable in the wrong place. Whoops. Is 1 greater than or equal to minus 2 times 2 plus 11? Minus 4 plus 11 is 1 greater than or equal to 7. Still false, but not, got to be careful in there. All right, so now let's try for 1. So is 1 greater than or equal to minus 2 times 4 plus 11? Is this true?
8. 11 minus 8 is. Yeah, 3. No.
So again, this is not true, so that's out. Let's go to the next one here. Is 5 greater than or equal to minus 2 times 4 plus 11? Is this true?
Yes.
5 is greater than or equal to 3. So that's true. Now we got to try it in the other one. Is 5 greater than 3 times 4 minus 9?
Uh, 3. Yes.
Yes. So this would be our correct answer. Okay, so the problem I'd like you to try, and we're not going to go into standardized test prep, but these are good questions. They're really related to what you've been doing. I'd like you to just try one here. So again, you're just going to test the points, until you find one that works in both. You can read the question if you want, but go ahead and see which one works in both.
When graphed in the xy plane, what point xy is the assumption of the given system inequality? For no. D.
How confident are you in your answer?
Well, I was like 93%, but now that you
Okay.
said that,
No, it's an important question. The reason is like you want to have confidence in your answer regardless of whether you're right or wrong, because doubt will cause you to spend more time on the question. So you should say B, I know it's right, and I'm moving on to the next question. Now, because we have time here, I'm going to check, but that is the point here, which may seem counterintuitive. Is like, why would I want confidence if it's wrong? Because you don't want to spend any more time on this question than you have to. Like, if you think you've got the answer, move on. Time is always working against you. So let's check it out here. Is -2 greater than 4 times -2? Is -2 greater than -8? That is true. Now we're going to try it in the other one. Is -2 less than -2? Is -2 less than 2? Yes, it is. Good. Okay. So we'll come back to testing points here in a moment, but let's get back to graphing another inequality. Let's say we're going to graph y equals 6 minus, oops, I didn't get the inequality in here. 6 less than 6 minus 3x. Okay. So again, like what you want to do is you want to really treat this as 6 minus 3x. Okay. Can you tell me the slope and the intercept in this case?
the slope is -3
Over what? And the
over
b
1,
value? And the b value?
+6.
Good. Okay, so if we're graphing this, if we're graphing a straight line or a line not an inequality, we go up to 6, 1, 2, 3, 4, 5, 6. Now what do I do from 6? What does the slope tell you to do?
Go down 3 to the right one.
1, 2, 3, right 1, 1, 2, 3, right 1. Okay, now is it a solid or a dashed line?
Dash.
Yeah, and you might even write that in the beginning. Okay, it's dashed. If you, for some reason, graph a solid one, you can always just erase little segments of it to make it look dashed. Just don't make it clear. Like, it doesn't need to be perfect, but don't like do that and like, don't confuse your teacher. Like, don't make them have to decide what you have interpreted. And if you're not sure,
Right.
just point to it and say that's dashed. Make it really clear. Now,
Right. Okay.
are you going to shade above or below, and why?
Below.
Below. Okay. So this is below, and it's because it's solved for y.
Right.
So I want you to test -5, 6 and tell me if that's true or false.
Uh, it is true.
It is true. Now, if I told you to test something that's pretty close to the graph, and that's where we could run into some issues you may or may not know if you haven't graphed it well. So always pick something far enough away. The origin's good. Origin's always really good, but make sure it's actually a place there. So what is all this leading to? I want you to solve, I'm sorry, I want you to graph, not solve. Graph, let's go 6x minus 2y less than 18. So just like earlier, you treat this like it's an equality
Right.
and you figure out how to graph that.
Uh, here. Nine. Uh,
The non-verbal body language suggests maybe you're not sure how to do this. Can I help in any way? Can I, what,
no,
can
wait,
you,
I think I got it.
okay, that's good. That's good. This is also the limitation of this format when I can't really see what you're doing. So I don't know if you're
Okay.
struggling or not, but that's good. I'll jump in whenever you think you've got a final answer.
Okay, I think I got something.
Okay, so when X is 0, Y is -9, and when Y is 0, X is 3. So that gives you 2 points to graph here. We'll just pretend like that's -9. So is it a solid or a dashed line?
A dashed.
Dashed line, okay. And then to decide whether you shade above or below, you can't do it as is. You have to solve for Y. Okay, so if you just arbitrarily shaded the underneath side because it was less than, that could be wrong. Might be right. You got a 50% chance. I don't want to take risks like that. So rather than solving this for Y, you should test a point like 0, 0.
Right.
That's what I was leading up to with those inequalities. You test 0, 0. Is 6 times 0 minus 2 times 0, is this true? Is this a true statement?
Yes.
It is. So this is you always shade the true side, and it's good to draw them kind of 90 degrees to the, you don't need to like do all this. Like that's not what they're looking for. Like less is more. They just want to see that you picked one side or the other.
Right.
All right. Any questions on that?
No, that helped a lot.
Okay, let's have you try one more. Graph minus X minus 2Y equals 4. Sorry, I got the inequality. I'm so silly sometimes. Okay, let's try that. So
Ooh,
again, let's give this one a try, please.
okay, so this is a lot easier to plan out.
Good to hear.
Uh, Done. I think I got a graph.
All right, so again, using the intercept approach, when X is 0, Y ends up being -2. When Y is 0, X is -4. It's a solid line this time. That's not gross. That's better. And then you test a point. I would test 0, 0 because it's far enough away. If you're ever not sure, just pick something further away, and that side does work. Any questions on that or anything more to cover?
No, that works.
Okay, so let's do some SAT prep line stuff. We'll just start out with some easy questions and easier, not easy. They're just not as hard as they can get. Take a look at this one, see what you come up with.
Um, which is the following is an equation of line L in X, Y, point. D?
Did you say D like dog?
Yes.
Yes, that is correct. So that's good. Sometimes again with standardized tests, they don't always say as directly as they could, like write the equation of the line. Like that's all that's needed. They just use a lot of extra words. All right, here's another one for you to try.
Oh, B.
Okay, and how confident are you in your answer?
Very confident.
Good, you should be. All right, here's a it's not a numerical problem, but you definitely know how to do it.
Um, where n is positive constant and x plus 3. So it has to be either A or C.
Okay, agreed.
So I'm going to go with A.
Okay, so give me a value of m.
5.
Okay, so let's say it was y equals 5x plus 3. There's 3. What's the slope?
5 up, 1 to the right. Oh, so it'd be C.
Yes. Now you wisely you got it down to 2. So if you were guessing, 50% chance. We're going to talk about that at some point. You should have a reason though for why you're guessing. You shouldn't just choose. Like that's not a good strategy. But you need some justification in your head. Again, that points to like the confidence. Like if you're like, I picked M is 5. Like I feel good about my answer. That's the kind of stuff we're trying to get you to do. All right. So here's kind of it is a line problem. It's just that it doesn't necessarily look like the kind of line problem you're used to. And again, that's just this test prep stuff here. So here's the graph. Get the graph here. Just have to snip that in separately. Here we go. Boom. Okay. Take a look at this. See what you come up with.
A. No. Yes, A.
Did you eliminate any answers? Did you?
I got rid of C and D because they were both starting at a point that this graph did not start at, which was positive 2.
Good.
And then after looking at it more carefully, I went with A because it goes up 2 to the right 1 and not up 1 to the right 2.
You got it. Okay. Here we go. I'll snip in a graph again, and then I'll snip in the question. All right, here we go. Go ahead and see what you come up with for that, please.
B.
It is
So
B.
so my thought process for this one was I looked at the graph and saw that it started at positive 3.
Mm-hmm.
So I looked for an intercept that was at positive 3, which was B or D. And then I checked to see the rise and run of each equation, and B was the most accurate to the graph, going down 3 into the right one.
Yeah, that's correct. And maybe before tonight you might have mixed up the two, but hopefully now it's clear that the top is the up or the down, the bottom is to the right,
Yes.
always
Thank
to
you.
the right. Yeah. We read left to right, graphs go left to right. There is some order in the math world. All right, here we go. Another one for you to look at. See if you can come up with the right answer here.
I'm gonna go with A.
Okay, so here a little uncertainty. I think what's maybe you're struggling with is like, well, I'm used to just counting, but this time when you count, they're going up by 2. So it's 2, 4, 6. That's your rise. And then your
Right.
run is 4 units this time. Sorry, not 2,
Right.
3 halves. So yeah, it's A. All right, last one here. And this is hard, but again, this is hard to do because you're doing it through a screen. I mean, I know that they're moving towards that on there, but yeah, on paper in front of you, sometimes these aren't as, there's no obstacles with your eyes or vision. But here you go, last one. See what you come up with.
Oh, I don't like this one. Oh, I have to think. Okay. Um, I'm thinking it's either A or C.
Okay, so this one, yeah, there's a number of ways to do it. It is C, just because we're running out of time here. You would use the intercept approach, meaning you would find the intercepts of each. So if you were to cover up the X, Y is -4. There's that. If you were to cover up the Y, X is -4. That's that point there.
Right.
And that'll do it. Okay, we're gonna stop recording.